Slopes of horizontal and vertical lines. The slope of a horizontal line, a line with an equation of the form y equals b, where b is any constant. That means there are no x variables in the equation of that line. There's only a y and a constant. The slope of that line, that horizontal line, is always 0. So if we look at this line right here, its slope is 0. It is a horizontal line and it has 0 slope. Because if we were to figure out from 2 points on it, we would see that it would have no change in y. So it would be 0 over a number, which would be 0. The slope of a horizontal line is always 0. Now for the slope of a vertical line. A vertical line is a line with an equation of the form x equals a constant. And your book uses x equals a. There are no y's in it. It's an x only and a constant there, x and a number, and that's the slope. That's the equation of a vertical line, and the slope of that vertical line is always said to be undefined. Undefined. If we found 2 points on the line and subtracted them, we would see that there was no change in the x values, only a change in y, so it would produce a number over 0. And because we can't divide by 0, we say that is undefined. So that gives us 4 types of lines that we need to talk about and be careful of, and you should recognize right away when you see one which of the 4 it is. If the line is moving upward as you trace it from left to right, its slope is positive. But if the line is moving downward as you trace it from left to right, its slope is negative. If the line is straight across horizontally this way, its slope is 0. And if the line is vertical, straight up and down, its slope is undefined. And those are the 4 types of slopes we can see with lines. Now we want to talk about slopes of parallel lines. From a geometric perspective, parallel lines are just any 2 lines that never intersect. But algebraically, we say that they have the same slope. So if 2 lines are parallel, they are going to have the same slope. So for example, if I have a line y equals 2x plus 3 and y equals 2x minus 5, they are parallel because they're not the exact same line, but they have the same slope. Also, any 2 horizontal lines are considered parallel, and any 2 vertical lines would also be parallel, because they would both have undefined slopes. So example 5, it tells us that the lines in the figure to the right are parallel, and we would like to find y. If you look over here very, very closely, you can see that on the red line, there are 3 ordered pairs. One of them you know both the x and the y. One of them is missing the x, and the other is missing the y. We want to find the y value of this ordered pair. And all we know is that the red and blue lines are parallel. Because they're parallel, that must mean that their slopes are equal. So if I find the slope of the blue line, m equals y2, which is -2, minus y1, which is 4, divided by x2, which is 1, minus x1, which is -3. 1 minus -3. That gives us -6 over +4, which simplifies to -3/2. This is the slope of the blue line. It also has to be the slope of the red line. So let's take a look at the slope of the red line. I'm going to use this as ordered pair number 1 and this point as ordered pair number 2. I'm going to ignore this point because it's missing an x value, and I'm only interested right now in finding the y value. So I'm going to use the one I know and the one that's missing the y value. I'm going to calculate the slope of the red line between those 2 points. So the second y value is actually unknown. It's y. So we're going to say y minus the first one, which is 5, over the second x, which is 3, minus -2, which equals y minus 5 all over +5. So that's all I know right now about the slope of the red line. It still has a variable in it. However, I know that the blue and red slopes have to be equal because those lines are parallel. So algebraically, I can just set those two quantities equal to each other. Y minus 5 over 5 equals negative 3 over 2. That looks like a proportion. It's a fraction equals a fraction. So we could solve that by cross multiplying. 2 times y minus 5 is 2y minus 10, and that has to equal the other cross product, 5 times negative 3, which is negative 15. Now I have 2y minus 10 equals negative 15, and I can solve that for the missing y value. 2y has to equal negative 5, so 1y, when I divide by 2, has to equal negative 5 halves, or negative 2.5. So take a look over here, and we noticed that this is the point positive 3 comma something. And because it's a pretty well-drawn sketch, you can see that the y value is between negative 2 and negative 3. So it seems that our y value makes sense. You could also go back and substitute that value in and do the slope over to make sure that it gives you negative 3 halves when y is negative 2.5. And finally, we need to talk about the slopes of perpendicular lines. Your book defines this a little differently than probably you learned in Algebra 1 and Algebra 2, but that's okay. We'll kind of connect them and try to make them both make sense to you. Your book says that if two non-vertical lines are perpendicular, then the product of their slopes is negative 1, which sounds a little weird. Basically what that means is that if they are perpendicular, if the two lines meet at a 90-degree angle, then if you take the slopes of those two lines and you multiply those two slopes together, it has to always equal negative 1. Another way of saying that is that perpendicular lines have slopes that are opposite reciprocals. Opposite reciprocals. What that means is that if the slope of one line is 2/3, then the slope of a line parallel to it would have to be the opposite, and the opposite of positive is negative, and the reciprocal. The reciprocal of 2/3 is 3 halves. So these two slopes could be the slopes of two perpendicular lines. Furthermore, if you multiply these two guys together, you would get negative 6 over positive 6, which is negative 1. And that's what your book is saying. Your book is saying that at the end they have to multiply to negative 1. But for a standpoint of just usability, it's easier for us to say that they are opposite reciprocals. That means more to us and allows us to get to the answer a whole lot faster. So let's look at an application of this. Here we have a figure that has two lines on it, and we need to know if these two lines are perpendicular. So let's start out by looking at the red line, or what appears to be the red line, right here. The red line contains the points 0, 0, which is the origin, and the point 3, negative 4. If I calculate the slope between those 2 points, the red line gives us negative 4 minus 0 divided by 3 minus 0, which is negative 4 over 3. So the red line has a slope of negative 4/3. I can't really tell the color of the other line, but let's just pretend that it's blue. The blue line runs through the points 3, negative 4, and be really careful, this point isn't on the line. It's just there to kind of throw you off track. So it does run through the point 3, negative 4, that's where they intersect, but it also runs through the point 9, 4. So those are the 2 points I need to use to calculate the slope of the blue line. M equals, let's see, second y is 4 minus negative 4 over the second x is 9 minus 3, which equals positive 8 over positive 6, which will simplify to 4/3. So there are the two slopes, and we need to compare those slopes and decide whether these two lines are perpendicular. Well, the first slope is negative 4/3. Negative 4/3. And the second slope is positive 4/3. Positive 4/3. They are opposites. One is negative, one is positive, but they're not reciprocals. In order for these two things to be opposite reciprocals, the second one would need to be positive 3/4, not positive 4/3. So we know right now that these two lines are not perpendicular. We could also go a little further and multiply the two lines together and see that that gives us negative 16 over 9, which is not negative 1. And to be perpendicular, they would need to multiply to negative 1. They would need to be opposite and reciprocal. So these two are not perpendicular. So the answer is simply no. And that wraps up lesson 2.2.